Welcome second year B.Sc student, paper number MTS 301, calculus of several variable. Video number 28. Unit number 4, double and triple integration, and this is video of double integration. Dear friend, subscribe my YouTube channel PV Patil. Double integration definition. Let f of xy be defined for all points in a finite region R of xy plane. Let delta x delta y be elementary area of region R surrounding the point xy. Then limit delta x tends to 0, delta y tends to 0, sigma of sigma f of xy delta x delta y is written as double integration over R f of xy dx dy and is called double integration of f of xy over the region R. This is definition of double integration. Now evaluate some double integration. First example. Evaluate integration limit 0 to 1, integration limit 0 to 1 dx dy. Solution. Integration limit 0 to 1, integration limit 0 to 1 dx dy is equal to. Now first one, integration limit 0 to 1 and evaluate this integration. Integration limit 0 to 1 dx is x, limit from 0 to 1 dy. Now here first put the value of x is 1, then put the value of x is 0, 1 minus 0 is 1. So equal to integration limit 0 to 1, 1 minus 0 dy equal to integration limit 0 to 1 dy, and integration of dy is y. Integration dy is y, limit from 0 to 1 equal to 1 minus 0 is equal to 1. Answer is 1. Example second. Evaluate double integration whose first integration limit 1 to 2, second integration limit 0 to 1 xy dx dy. Solution. Integration limit 1 to 2, integration limit 0 to 1 xy dx dy is equal to integration limit 1 to 2. Now evaluate this limit with respect to x. Integration 0 to 1 xy dx is y constant and integration of x with respect to x is x square by 2. Y constant, integration of x is x square by 2. X varies from 0 to 1 dy. X varies from 0 to 1 dy. Equal to, we get 1 half. First one, 1 half is constant. Integration limit 1 to 2. Now here y constant. Now put the value of x is 1. So 1 square minus of, put lower limit, put x is 0. So y into 0 dy. Therefore equal to 1 half integration limit 1 to 2 y dy. Y into 1 is y dy. Now integration of y is y square by 2. So 1 half integration of y is y square by 2. Y varies from 1 to 2 is equal to 1 by 4. And first put upper limit, then put lower limit equal to 1 by 4. First put the value of y is 2, so 2 square minus put the value of y is 1, so 1 square equal to 1 by 4 inside the bracket 4 minus 1. 4 minus 1 is 3, so answer is 3 by 4. Next example number 3. Evaluate integration limit 0 to 4. Next integration limit 0 to root y xy dx dy. Solution. Integration limit 0 to 4, integration limit 0 to root y xy dx dy equal to integration limit 0 to 4. Now evaluate this integration. This is integration with respect to x. So y is a constant and integration of x. Integration of x is x square by 2 and limit x varies from 0 to root y dy. Now is equal to, we get integration limit 0 to 4. Now here first put upper limit value of x as root y, so y into root y square upon 2 minus put value of x as a lower limit, x is 0, so y into 0 upon 2 dy. Root y square is y, y into y is y square by 2 and this is 0 equal to integration limit 0 to 4 y into y upon 2 minus 0 dy. 1 half constant and this is y square. 1 half out of the integration limit 0 to 4 y square dy. Integration of y square is y cube by 3. 1 half integration y square is y cube by 3, y varies from 0 to 4 is equal to, we get 1 by 6. This is 3 2s are 6. First put upper limit 4 cube minus 0. Y equal to 4, 4 cube minus 0. 4 cube is 64 upon 6. Divide by 2, we get 32 by 3. Example number 4. Evaluate integration limit 0 to 1, integration limit 0 to 1, x square minus y square dx dy. Solution. Integration limit 0 to 1, integration limit 0 to 1, x square minus y square dx dy is equal to integration limit 0 to 1. Now evaluate this integration with respect to x. Evaluate this integration with respect to x. Integration of x square is x cube by 3 minus of y square constant, integration dx is x, and limit from 0 to 1 dy. Now here first put value of x as upper limit 1 and then put value of x as lower limit 0. Equal to integration limit 0 to 1, put x is 1, so 1 by 3 minus y square. Minus of, put value of x is lower limit 0, so this is 0 and this is also 0. So minus 0 dy equal to, now evaluate this integration with respect to y. So 1 by 3 integration dy is y minus of integration of y square is y cube by 3, y varies from 0 to 1. Now first put the value of y is upper limit 1, so this is 1 by 3 minus 1 cube by 3 minus of, put the value of y is 0, so 0 minus 0 equal to 1 by 3 minus 1 by 3 equal to only 1 by 3 minus 1 by 3 and is equal to 0. Example number 5. Evaluate integration limit 1 to 2, integration limit 0 to 1, x square plus y square dx dy. Solution. Integration limit 1 to 2, integration limit 0 to 1, x square plus y square dx dy is equal to integration limit 1 to 2. Now evaluate this integration with respect to x. Evaluate this integration with respect to x. Integration of x square is x cube by 3 plus integration y square dx, y square constant, integration dx is x, means xy square, and limit x varies from 0 to 1 dy. Now first put upper limit, value of x is upper limit 1, so integration limit 1 to 2, 1 by 3 minus y square. Now put the value of x is 0, so 0 minus 0 is 0 dy. Now evaluate this integration with respect to y. So 1 by 3 and integration dy is y plus integration of y square is y cube by 3, y varies from 1 to 2. Now first put upper limit 2, so this is 2 by 3 plus 2 cube by 3 minus of, put lower limit y is 1, so 1 by 3 plus 1 by 3 equal to, we get 2 by 3 plus 8 by 3 and minus of 1 by 3 plus 1 by 3 is 2 by 3 plus 2 by 3 minus 2 by 3 cancel, remains only answer is 8 by 3. Next, example number 6. Evaluate integration limit 0 to 1, again integration limit 0 to x square e raised to y upon x dy dx. Solution. Integration limit 0 to 1, integration limit 0 to x square e raised to y upon x dy dx is equal to integration limit 0 to 1. Now evaluate this integration with respect to y. This is integration with respect to y. Now here function is e raised to. We know integration of e raised to is e raised to and divide by coefficient of y. Integration with respect to y, so divide by coefficient of y. So integration of e raised to y upon x is e raised to y upon x, divide by coefficient of y 1 upon x, and y varies from 0 to x square dx equal to, we get integration limit 0 to 1, 1 upon x means into x, so x into e raised to. Now here put the value of y is x square first, e raised to x square upon x minus of x into e raised to, value of y is 0, so e raised to 0 dx equal to, we get integration limit 0 to 1 x e raised to x minus x e raised to 0 is 1 dx. Now here x common, integration limit 0 to 1, x common into bracket e raised to x minus 1 dx. Here x common into bracket e raised to x minus 1 dx. Now this is u into v form, so apply integration by parts here and integrate this u into v form. First function is x, integration of e raised to x minus 1 dx minus of integration of d dx of x, integration of e raised to x minus 1 dx, and total bracket complete, and this integration dx, and limit x varies from 0 to 1 equal to x. Now integration e raised to x is e raised to x, and integration of dx is x minus of integration of derivative of x is 1, integration e raised to x minus integration dx is x dx, x varies from 0 to 1 equal to x e raised to x minus of x into x is x square minus integration e raised to x minus x dx, x varies from 0 to 1 equal to x e raised to x minus x square minus of integration e raised to x is e raised to x, this minus and minus become plus, x square by 2, x varies from 0 to 1 equal to, now here first put upper limit, value of x is 1, so 1 into e raised to 1 is e minus 1 minus e raised to 1 is e plus 1 half minus of, put x is 0, so this is 0, this term is 0, e raised to 0 and plus 0. Simplify this, we get plus e minus e cancel, minus 1 plus 1 half, minus 1 plus 1 half, and this minus and minus become plus 1. Plus 1 minus 1 cancel and is equal to 1 half. Answer is 1 half. Next, problem number 7. Evaluate integration limit 1 to 2, integration limit 0 to x, dx dy upon x square plus y square. Now here integration limit 0 to x, x means this is value of y. This is integration limit y varies from 0 to x, dy upon x square plus y square dx. So integration 0 to 2, integration 0 to x dx dy upon x square plus y square is equal to integration limit 1 to 2. Now here this integration y varies from 0 to x dy upon x square plus y square dx. Now evaluate this integration first. Now this integration is in the form 1 upon a square plus x square dx. Use this formula for this integration, and we know this formula is 1 upon a tan inverse x upon a. Here a is x and x is y. So this is 1 upon x. Integration of this term is 1 upon x tan inverse y upon x. Integration limit 1 to 2, inside the bracket 1 upon x tan inverse y upon x, and y varies from 0 to x dx. Now first put the value of y is x upper limit, so integration limit 1 to 2 1 upon x tan inverse. Put the value of y is x upon x minus 1 upon x tan inverse 0. Put the value of y is 0, tan inverse 0 dx. This is tan inverse 1, tan inverse 0 is 0. Integration limit 1 to 2 1 upon x tan inverse 1, tan inverse 1 minus 1 upon x tan inverse 0 is 0. Now 0 into 1 upon x means this term is 0. Tan inverse 1 is pi by 4. Integration limit 1 to 2 1 upon x into pi by 4 dx. Pi by 4 is constant out of the integration. Integration limit 1 to 2 1 upon x dx. Now integration 1 upon x is log x is equal to pi by 4. Integration 1 upon x is log x, limit from 1 to 2. Now first put upper limit 2 and then put lower limit 1. So equal to pi by 4 inside the bracket log 2 minus log 1. Now we know the value of log 1 is 0. So equal to only pi by 4 log 2 is the answer. Pi by 4 log 2 is answer. Example 8. Evaluate integration limit 0 to 1, integration limit 0 to square root 1 plus square dx dy upon 1 plus square plus y square. Consider integration limit 0 to 1, integration limit 0 to square root 1 plus square dx dy upon 1 plus square plus y square. Now here the limit of integration 0 to square root 1 plus square means this is in terms of x. This is in terms of x means this is value of y. This integration y varies from 0 to square root 1 plus square means dy upon. See here, first integration limit 0 to 1, inside the bracket integration limit 0 to square root 1 plus square dy upon 1 plus square is square root 1 plus square its square plus y square. Now this is integration with respect to y into dx. Now for this term use the formula of integration 1 upon a square plus square dx equal to 1 upon a tan inverse x upon a. Use this formula here. Use this formula 1 upon a square plus square is 1 upon a tan inverse x upon a. Here a is square root 1 plus square and x equal to y. Therefore equal to integration limit 0 to 1. Now here 1 upon a, so 1 upon square root 1 plus square into tan inverse y upon a, y upon square root 1 plus square, limit y varies from 0 to square root 1 plus square dx. Now here first put the value of y is square root 1 plus square, then put the value of y equal to 0. So equal to integration limit 0 to 1, 1 upon square root 1 plus square into tan inverse square root 1 plus square upon square root 1 plus square minus 1 upon square root 1 plus square into tan inverse 0 dx. This is square root 1 plus square upon 1 plus square means 1. This is tan inverse 1 and tan inverse 0 is 0. So 1 upon square root 1 plus square tan inverse 1 minus 1 upon square root 1 plus square into 0 dx. Now this term is 0 and tan inverse 1 is pi by 4. So integration limit 0 to 1, 1 upon square root 1 plus square into pi by 4 dx. Now pi by 4 constant out of the integration, pi by 4, integration limit 0 to 1, 1 upon square root 1 plus square dx. Pi by 4 constant, integration limit 0 to 1, 1 upon square root 1 plus square dx. Now use formula integration 1 upon square root a square plus x square. 1 upon square root a square plus x square. Formula is log of x plus square root 1 plus square. Pi by 4 constant. Integration of this term is log of x plus square root 1 plus square. Integration limit x varies from 0 to 1. Now first put upper limit pi by 4 log of. Put the value of x is 1 plus square root 1 plus 1 minus put x is 0 log of 0 plus square root 1 plus 0 is equal to pi by 4 log of 1 plus root 2 and minus of log 1. This is log 1. Value of log 1 is 0. So answer is pi by 4 log of 1 plus root 2 is equal to pi by 4 log of 1 plus root 2 is the answer. Example number 9. Evaluate integration limit 0 to 1, integration limit 0 to 1 minus y. Function is y minus root x dx dy. Now here integration limit 0 to 1 minus y means these are values of x. This integration x varies from 0 to 1 minus y. Bracket function is y minus root x into dx then dy. Therefore integration limit 0 to 1, integration limit 0 to 1 minus y, inside the bracket y minus root x dx dy equal to integration limit 0 to 1. Now integrate this with respect to x. Now here in first term y constant, integration dx is x, y into x minus integration of root x means integration of x raised to 1 half. Integration of x raised to 1 half is x raised to 3 by 2 upon 3 by 2. Limit x varies from 0 to 1 minus y dy. Now first put the value of x is 1 minus y minus put the value of x is 0 equal to integration limit 0 to 1 inside the bracket y. Put the value of x is upper limit 1 minus y minus of 1 upon 3 by 2 means 2 by 3. Put the value of x is 1 minus y raised to 3 by 2. Now put the value of x is 0, so this is 0. Put x is 0, this term is 0, means all in x term 0 dy. Equal to we get integration limit 0 to 1. Now open this bracket, y into 1 is y. Minus of y into y is y square. Minus 2 by 3, 1 minus y raised to 3 by 2 dy. Now integrate this with respect to y. First term, integration of y is y square by 2 minus integration of y square is y cube by 3 minus of 2 by 3. Integration 1 minus y raised to 3 by 2 is 1 minus y raised to 3 by 2 plus 1 is pi by 2 upon pi by 2. Also divide by coefficient of y minus 1 and y varies from 0 to 1. Equal to we get, first put upper limit, put the value of y is 1, so 1 half minus 1 by 3 minus of this minus and minus become plus. This 2 is in numerator, 4 by 15. Put y equal to 1, so 1 minus 1, 0. Minus of, put lower limit, value of y is 0, so this term is 0. Next term is 0, plus 4 upon 15 and put y is 0, so 1 raised to 5 by 2 is 1. Is equal to 1 half minus 1 by 3. This term is 0, then this term is minus 4 by 15. Now throughout LCM is 30. LCM of all these three terms is 30. So multiply here by 15, multiply here by 10 minus 10, multiply here by 2 minus 8. 15 minus 10 is plus 5 minus 8 is minus 3 by 30 is equal to minus 1 upon 10 is the answer. Dear friend, subscribe the channel and share to our friend. Thank you.